Just as we have our traditional sense organs, as they are often called, our eyes, ears, skin, tongue, and our nose, and they send signals to our brains to help us better understand our environment. The Arduino can also receive signals from external sensors to interact with its environment, and it does that through the set of input pins, the digital and analog pins. Let's begin with the digital input. Inputs alone to the Arduino will be meaningless without conditional statements. So we have available conditional statements like the if statement, the if-else statement, the if-else statement, the switch case statement, and others. We will limit ourselves to these two for this video, while we get others later. The if statement executes the code it contains only if a condition specified is true. Now its syntax is if bracket open condition bracket close, then curly brackets open, and then we write the code to be executed if the condition is met. The code we are writing here, okay, is going to be executed if the condition, if the code we wrote inside this bracket is met. Then we close the function with a curly bracket, and that's it for the if statement. The if-else statement executes a set of codes if true, but executes a different set if the condition is false, and its syntax is the if condition curly bracket open, then we put down the code that is to be executed if the condition is met or if the condition is true, and then we close our curly brackets, and then we begin the second part of our statements, and then we have a curly bracket there open, then we write down the code that is to be executed if the condition is false. Note that we are talking about this condition. The code you're writing here is to be executed if this condition is true, and the code you're writing here is to be executed if this condition is false. Okay, so let's try this out in our IDE. Okay, so here we have our blink sketch, which we used in our previous video. So we're going to add to this a conditional statement to blink the LED faster when we press a button. Okay, so just to clean out this, let's delete these notes and delete as much notes as we can because we don't really need them anymore. Okay, so we have our void setup, we have our void loop. Okay, then also remember I told you LED underscore built-in is pin 13, and the reason why we're using LED underscore built-in is because LED underscore built-in is already declared within the system codes, so we could just use LED underscore built-in and the system, the IDE will understand, or the compiler will understand that we mean pin 13. Okay, so for simplicity and to erase confusions that might erupt, let's change it all to pin 13. Okay, so before we come back here, let's build our circuit. So we have our LED, and the longer part of it is the positive. The longer part is positive while the shorter part is negative. So we'll connect that to our breadboard, and then we'll connect the positive part of the LED to the pin 13 of the Arduino, and that's because in our sketch we have declared pin 13 an output and have sent our blinking signal to that pin. Okay, so we'll just make use of it, and then we're going to connect a resistor to our LED to limit the current flow through it. So we're using a 1K resistor and we connect it to ground. The red rail is connected from this point down to the last slot, while the blue rail is connected from this point down to the last slot. So all we need to do is to pick any of them and connect it to the ground of the Arduino, and we have the ground of that resistor connected. But then we want to connect a push button to our circuit so that whenever we press the push button, we would have our LED blink faster. Okay, so let's do that now. So that's our button on the breadboard. So we connect one pin of the button to ground, and we connect the other pin of the button to pin 8. Alright, so we're going to be using pin 8 as an input pin to send a signal from the button. Okay, now when we have pins declared as input, okay, it means we are not assigning them a high value or a low value. They're just supposed to sit and wait for signals, sense them, and then the microcontroller can carry out a function once it senses this signal. But if we leave them floating, that is, leaving them without a known voltage level, they can take up a random voltage level from electrical noise and other sources. Okay, so it's important to make them have a known voltage level. We want to give it a stable known voltage level, and so since we want it to carry out a function whenever it senses 0 volts on pin 8, let's make pin 8 always high. So when we send a low to pin 8, it will sense it. So one way to do it is to connect a pull-up resistor to pin 8. Okay, so we have our pin 8 connected to this pin. We can then connect this pin via a resistor to 5 volts. Okay, and then we can connect that positive rail to 5 volts on the breadboard. We have 5 volts just after ground there. So since we've connected our 5 volts to our positive rail, we are done with this. So let's finish with our code, and then we send it across to the Arduino and see how it functions. Okay, so back here we bring in our code for the button, and then we compile and send to the Arduino. So let's see how that goes. Okay, so first of all, we know our button is connected to pin 8. Okay, so let's declare pin 8 an input pin. So we have pin mode eight. Remember, these are syntax, and when writing our codes, we have to put our words in its proper order. Pin mode is different from pin space mode. It's different from pin small letter m then ODE. Alright, the IDE doesn't understand this. Okay, it understands this arrangement. Then your input should be all in capital letters. That's how the IDE understands it. Okay, and remember, we have that put in our setup loop because this is going to be happening just once. We're declaring this as input just once. Once the microcontroller knows this, it doesn't have to come back to it again. Every other thing we would write in the loop function, because that's what we need the microcontroller to, or the Arduino to, repeat over and over again. So we come to the void loop. Okay, so we have to put our quotes before the curly bracket closes. Okay, so it is within the loop function. Okay, so how do we get this Arduino to blink the LED faster when we press the button? We're going to use an if statement. Okay, so we're going to write this: if digital read we have the brackets open and close pin. This is the syntax for digital read. Okay, then we have that to be equal to low. Close the brackets, open up a curly bracket, and we can copy this into our code here. Okay, so what we're doing is if this condition is met, we need pin 13 to be written high. Delay it for this case will take 200 milliseconds. Then write it low and delay it for another 200 milliseconds. Okay, so I made an obvious mistake here, and let's see if we can compile this. Okay, so if we click for the IDE to compile this, we'll see it to point out errors. Okay, so we have digital read was not declared in this scope. All right, so I actually wrote digital, not digital. I didn't even know I made that mistake. Okay, the obvious mistake I made was my if. Okay, it's supposed to be small letter I and small letter F. All right, that way the compiler understands what we've written, and so it should compile now unless there's any other mistake. All right, so we have that compiled. Let's send this to the Arduino and see how it behaves, because I know this is not going to behave exactly how we want it to behave, but let's see what happens. So I connect the Arduino. Alright, so we can see that we have the Arduino blinking, and that's because we had previously sent the blink code to the Arduino, so it's just carrying out the program. So now we compiled, but we did not send, so let's upload now to the Arduino. Okay, so it's done uploading. Alright, so let's press our button and see if we have 20 seconds flash. So we can see that when we press our button, the light comes on for 20 milliseconds, turns off for 20 milliseconds, but then remains on for 1 second. We can see that, right? Turns on for 200 milliseconds, turns off for 200 milliseconds, but comes on again for 1 second before going off. When we take our hands off the button, we have 1 second turn on, 1 second turn off. Okay, but that's not what we wanted, and that's because of how we wrote our program. Now the Arduino executes program line by line, and so what we told it to do was, once the Arduino turns on, once it turns on, it should write pin 13 high, delay for 1 second, write pin 13 low, delay for another second, and then now read pin 8 to see if pin 8 is low. If pin 8 is low, then make pin 13 high for 200 milliseconds and make pin 13 low for 200 milliseconds or 0.2 seconds. After that, go back, make pin 13 high again for 1 second, make pin 13 low for 1 second, and then after you have done this, now check if pin 8 is low. Do we get? So we're not going to get what we really want, and that's why you see after it has sensed pin 8 is low and it goes through this programming up to this point of being low and delaying for 200 milliseconds, it goes back to turning it on for 1 second and off for 1 second, then back. All right, so how do we make the Arduino do what we really want? Okay, so we can do this easily by the if else conditional statement. So all we need to do now is to add our else here. Okay, we have our curly brackets, and we have our curly brackets there for the close. Okay, so in between here we're to put in our executable code that should happen if this condition is not met, and if this condition is not met, we want it to run through this code. So let's take this code out of here, let's cut it and place it within our else. Okay, so this is what we have now. We have if digital read, if pin 8 is low, run this code, else run this. Okay, so we're going to see we have exactly what we want, which is having the Arduino blink for 200 milliseconds on and off throughout once the button is pressed. Alright, but then let me also talk about this. We have two equal signs here. We did not use one equal sign here because one equal sign means assigning. You are assigning a value to a variable, while when you have equal signs, two equal signs, you're not assigning, you're comparing. So we're asking the Arduino to compare the state low, which is 0 volts, to the state at which pin 8 is. If the state is the same, if pin 8 state equals the low state, do this. If it doesn't equal it, then do what we have here in the else function or the else statement. Now, it's different from assigning. So when we want to assign values to variables, we use one equal to sign. But when we want to compare states or values, we use two equal signs. Alright, let's compile this to see if we have any issues. So we had more than enough curly brackets and I had to delete one, and that's because our loop function has a curly bracket here opened, so it should have a curly bracket closed, and it should be the last one to show that everything here is within it. Okay, now we have the if function with a curly bracket opened here, and we have it closing here. We have else opening here, and we have it closing here. So we have just enough. We have our code compiled, so let's send it to the Arduino and get to see how it responds this time. Okay, so it's done uploading, and we see we have our LED blinking for 1 second, turning on for 1 second, and turning off for 1 second. So if I press the button, you see we have a steady flash for 0.2 seconds. All right, there's no more 1 second wait in between anyway. And then when we take our hands off, we go back to 1 second blink. So one more thing, let's note that the Arduino has a built-in pull-up resistor and can be activated in code. Okay, so we do not need to use a pull-up resistor on our circuit. We could just use the pull-up resistor in the Arduino. All right, and we can do that by typing here, changing this input. Of course, when we declared pin 8 an input, changing that input to input underscore pull-up. Okay, so if we do this, then we won't need an external pull-up resistor on our circuit. All right, except of course for more sensitive situations where we want to use a different value of a resistor for certain reasons. Otherwise, we wouldn't need to. Okay, so we can compile this, and we'll see we're still good. Okay, so you can try sending this to your Arduino and checking to see if you can actually use it without a pull-up resistor. And then if you have any issues, you can always say something in the comments, ask a question, make a suggestion, and I'll be happy to respond and help.